Hello, my name is Keith Rucker. So this will be the second part of a two-part series on restoring an Oliver C-fence that goes on an Oliver 80 table saw. We've already got the actual fence part back here restored, the guide part with all the mechanism in here that adjusts, making some new tight down screws here. But we've still got the other half. This is the part the tube goes in that all this slides in and out on. And as you can see, it's pretty rusty. It's a mess, and we're going to have to remake several parts on here. So just to kind of give you an idea of what's all going to be involved here. So obviously all the cast parts have got to go in the bead blaster, get cleaned up. We'll go ahead and put a coat of paint on those. These are in pretty good shape, the cast iron parts. The steel parts, they're toast. You can see the tube here. Basically this piece here slides on this tube, and you can see where it's just so rusted and pitted. So I've got another piece of tubing ordered. I didn't have a piece in stock here and couldn't actually find one the exact right size. This is an oddball size, one in, I can't remember, it's like 13/16 inch outside diameter, I think is what it is. And so I ended up having, I think it was 13/16, ended up having to get a 1 7/8 and or something like that. And we're going to have to turn that down on the lathe, polish it up, and get a new tube made. So anyway, that'll be coming up a little bit later in this video. I don't have that piece of metal in yet. Should be coming in here in the next day or two, and we'll get that knocked out. Also, there's a micrometer adjustment on this, and this is just a little piece that goes into this here. Well, actually goes this way, I think, but still, or no, it goes over here. There you go. So anyway, this right here, you can turn it and adjust it. This is graduated on here. I'm not sure if that's in like 30/2 of an inch or 1,000ths of an inch. I got to figure that out. But we're going to have to make all this new. This is just, I guess you could reuse it, but it looks terrible, and we want this thing to look really nice. So we're just going to make a whole nother assembly here. These are two pieces. They press together. There's a tapered pin that goes in there that holds it together, and that allows that to turn on the shaft, and again gives you that micrometer adjustment. So those will be made on the lathe. And then there's also two lock pins that pin this down to the table, and these pins are toast. It's just eroded away. They're rusted away almost halfway through on one of them. So we're going to have to make some new pins as well. And then finally, another lock handle. We made some for the backside here, but that's not original. I've got some drawings and dimensions of what an original one looks like, so we're going to have to make a new little T-handle that's the proper for this, rather than this is just a piece of steel welded onto the end of a bolt. You know, again, functional, but we're trying to make this right, so we're going to do it right. So anyway, we're going to get started. I'll probably start by bead blasting this and getting some paint on this and let that start drying. Then we'll get over in the lathe and start making some of these other parts. So first thing I'm going to do, I think, is work on making this knob for the micrometer adjustment. And I've just got a piece of steel in here, and we're going to turn this on here. So we'll turn that down to the right outside diameter, come in here, knurl it, and then I'll go ahead and machine the rest of it off. And so let's get going. So we need to get that down to 2-inch 375. Right now we're at about 2-inch 592. So got a little over 200 thousandths to cut off of it. Alright, I've had to make a little change here. I need to knurl this, and the only crosshatch knurling tool I got actually fits my older, smaller tool post holder. It's built right into the holder, so it's not a piece that I can put into my larger one. So I've taken the CA holder off and I'm putting this smaller tool holder back on here, which is what I used to use on this lathe. And now I need to get my knurling tool set up for to go. So with knurling, it's very important, first off, that the front of this be perfectly square with the part that you're working on. So I've already faced the front of my part here, so I'm just going to come in here to the side and we'll bring this over and just kind of square it up using the front of that part with the tool itself. And that should get me running square. And we'll just tighten this down. This may be hard to see on the video, but maybe we can see this. So now that I've got this set square, the next thing I want to do is adjust this up and down so that both of the wheels are engaging into the workpiece at the same time. And the reason is this is going to be a crosshatch knurl, and there's two wheels on here. There's one to do the left and one to do the right, and they both need to be cutting, and for it to be done properly, they both need to be engaged onto the metal at the same time. So to do that, I'm just going to come in here and feed this real carefully, real slowly, and watch those two wheels and make sure they both start turning at the same time. And you saw there the bottom one was not quite engaged, so I'm going to raise this up just a touch. Come in here and do that again. Now the bottom one's engaged, so it's just a little bit of trial and error. And there you go, they're both engaging at the same time. So now we've got that knurling tool set at the proper height. We're set back up here, and this needs to go down to 1.25 inch diameter there, and that is 1 inch deep. So we'll go ahead and start cutting this and take that down 1 inch deep to 1.25 inches. So some people have been asking about speeds and feeds and what have you. So right now we got the lathe running at 295 RPM, so let's just say 300 RPMs. The feed rate is set to 5.9 thousandths per revolution. So again, just rounding it up about 6 thousandths per revolution. And I'm taking a 100 thousandths cut, which of course will reduce the diameter by a total of 200 thousandths. So we're to the point now where we got to come in here and kind of cut this little necked out section in here. And there's a radius on either side. So what I've done is I've actually ground me a little nosing tool out of some high-speed steel that I can come in here that has a radius on it, come across there, and hopefully get that radius in on each side. So anyway, we're going to put this on here and give it a try. Starts at about 1/4 inch. Just come in here real quick, just make sure that my tool's set good. Not going to hit on anything. Diameter in here needs to be about 1 inch. So we're about 110 thousandths large. Now when you drill a 1/2 inch hole through this for the threaded part to press into and be pinned into, so we'll start by putting a center drill in there and then run a 1/2 inch drill bit through. Now we're going to part this off at about 1/2 inch thick. Turned it around in the lathe now, and it's going to come in here and just face the back side of this, so to get a nice clean surface on the top. Alright, show you where we're at here. So we got the the handle made from the micrometer adjuster, and it's pretty much just like the other one. Might be just a little bit thicker on this part here, but you know, I kind of like the extra thickness on that to give you a little bit extra thing. But I measured them, it's about 50 thousandths wider, but I'm going to leave it like that. Alright, so the way this works is you know, you got the knob back here. This piece comes in this side. It goes through that hole, it presses up on there, and that captures that in there so that when you turn this, it's going, and then that actually goes into this piece. This is clamped down to the tube, and you can do a fine adjustment by turning this. So the next step is we need to remake this, and that doesn't look too bad. I actually put it on the wire wheel and cleaned it up, got the rust off. But there's an awful lot of pitting and a lot of metal lost in these threads where it was so bad rusted. And you know, again, you could probably get by reusing that. This part here that was pressed up inside of there, I mean, that looks great. But this part down here is pretty bad, so we're going to go ahead and remake that. So I've got a piece of 1-inch stock. This is 3/4. I'm just going to turn it down. But I've been looking at trying to figure out the best way to do this. I could just chuck it up and cut one side and flip it around and cut the other. But I'm looking at it, and there's actually centers on both sides. And I think originally this part was turned between centers. And just to keep it in true with the way it was made originally, we're going to do the same thing. And you know, I've talked about turning between centers before in some of my videos, but I really like that, particularly if you need to keep a part where it's running concentric on both sides. Need to flip it over and do something on both sides. Turning between centers is a great way of doing that, because anytime you put it in a chuck, we know without putting it in a 4-jaw chuck and taking time to indicate it in, it's really hard to get one side turning true from the other side from chucking. Whereas turning between centers, you can just flip the part over between the centers and boom, you're ready to go. Turning between centers was used a lot back in the old days in old school machine shops. Nowadays you really don't see it that much, but it's still a good technique, particularly for one-off parts like this. So that's what we're going to do. We'll put this piece in lathe, we'll face both ends off, get the length right, put a center in each end, and we'll turn it between centers. Alright, I'm going to true in my center now. I just got my compound set to 60 degrees. This is just something I'll chuck up, and I'll usually do this anytime I'm turning between centers. So I've got a little bit of run out in there now, and we'll just take care of this real quick here. I always true up my center right before I use it like this. And that's all I need. I'm not going to use it to go that deep, so that's good. Alright, so we got this between centers now. We got a drive center on this side. It's in the chuck, and the lathe dog is in here driving against the chuck, so that'll be what powers it. And of course this will be the live center on the other side. First step here is we should be at 1 inch on this, and we need to turn it down to 3/4 for the threaded end, so we'll go ahead and get that going. So we're moving right along on this project. You can see the old and you can see the new here. So I still need to drill and pin a hole in here to get this in place with a taper pin, but we have the knob. It's turned, it's knurled. It's pretty much just like the old original one, except all nice and clean. So one more step off this project. The next step in the project is going to be to go ahead and making the new tube. So I got a new piece of tubing in. This is just a piece of tubing that I had to order. And again, I couldn't find one that was the exact right size. This piece here on the outside diameter is 1.8125, which is 1 13/16. And I was able to get some 1 7/8, 1.875. So I've got a little bit to take off the outside of that. And also on one end, on this end right here, the tube's going to kind of press on top of a turn piece there and be pinned in place. And this inside diameter is 1.5625, which is 1 9/16. And we'll have to just bore that on the inside up a couple of inches. Let's see, that's 2 inches deep there. So we'll bore that on the inside probably first, get that right, and then we'll set this up and turn the outside down and get it polished up and ready to go. We should have a new tube. We have the tubing set up in the lathe now, and as you can see, it's not going to fit through the spindle, so we had to extend it out. And this piece is about 3 foot by stock length here, so I've got it set up with the steady rest here to give it some support while we turn. And one of the nice things about having a nice long lathe is I've got plenty of room to do this. As you can see, I've got this set up, and I still have over half of my bed length here that I could work with something even longer than this. But anyway, this is set up. We'll just come in here and face this end off and bore it out now. We've only got about 75 thousandths to take out of this total, so not a whole lot of boring, but I've got my boring bar set up where it's just a little over 2 inches deep, and we'll just go the entire depth until right before that touches off, and we should be ready to go. So we'll probably take most of that bore in the first pass, and then we'll get a measurement and come back and clean it up on the second pass, hopefully. All right, we've taken the steady rest off now, and I've got a bullnose center in down here on the end just to give this support. And again, I only need to take about 60 thousandths total off of this, so I'm not going to get too aggressive. I'm going to take some light cuts. I did notice when I was boring down here that we got a lot of heat in this shaft or this piece of tubing, even just making that small cut. So what I've decided to do is I brought my little cool mist over here that I usually use on the milling machine, but it works fine on the lathe too. And we're going to just use that to try to, more than anything else, just to kind of keep this part cool. Unfortunately, this lathe, the coolant pump does not work on it. That's something I've been meaning to try to get fixed. I would love to have flood coolant on this lathe. It's set up to do that, but I need to pull that pump off and figure out what's going on, and just never seem to have time to do it. So for now, we're just going to use the cool mist. And again, I'm going to probably take about a 20 thousandths cut on the first pass, and hopefully I'll clean it up. I'm seeing some run out in here. This piece of tubing is not perfectly straight, but I feel like we should be able to clean it up just fine. But we'll just take a light pass here and then come back and probably sneak up on this rather than trying to hog it all off. Again, more than anything else, just to kind of keep it cool. We're going to take our time and do it that way. So because of the angle of the back of my cutter, I can't get it right up against this bullnose, so I kind of tilted the entire cutter over. Shouldn't be a problem. We're not going to turn it all the way to the end. We've got a little bit extra length on here, so I got a line marked here. That's as far as we need to turn it to. So I'll probably go a little bit past that and we'll just shut off and stop. So let's get going. All right, we finished up turning this on the lathe. All in all, it came out great. I do have one little thing I wasn't crazy about, and I didn't shoot all that on the lathe. It was just boring watching it go back and forth. But I got down to the very last pass. I need to take about 2 more thousandths off, and man, I had been getting a great finish. Everything was working great. And after I did that last pass here in the center, I got a little bit of chatter on there, and I didn't really notice it until I had shut the lathe off. It's not bad, it's not deep, but it's aggravating. I don't really like it, but I've tried everything out and it doesn't seem to be interfering with anything. It just doesn't look as great as I would like for it to. You know, the funny thing is that I was seriously considering making the last pass of this with my tool post grinder to get a ground finish on here, but I was getting such a nice finish just turning. I said, no, it's going to be fine. But chatter got me, and chatter is a common problem that people have on lathes. And you know, again, when I was taking the heavy cuts, it wasn't a problem. When I took that light cut is when it got me. And a lot of times when you have chatter on lathe, one of the things you can do to resolve it is to actually take heavier cuts, or to play with the speeds of the machine. The chatter comes from harmonics. With this being a hollow tube, it's almost like a bell ringing. And as that cutter's going across there, and when the speeds and feeds are just in the right spot in the depth of cut, you can get some vibrations. And a lot of times, if you just play around with the settings on the machine, either usually speed it up, sometimes slow it down, or speed up the feed, take a little bit heavier, faster cut. Sometimes that'll fix it. But because it was my last pass, you know, I really don't have a chance to go back and fix it. Again, it's not going to interfere with anything. I just don't like the way it looks. I may at some point in time actually come back and remake this part, but for now we're going to go with it. Like I said, I tried it out sliding the parts on there. It seems to be working fine, and it's not anything that's really bad. I mean, the chatter is only maybe a thousandth or two deep. I was only taking a 2 thousandths cut, or actually a 1 thousandths cut, 2 thousandths total. So I was just barely fuzzing some off, so it's not very deep. And I was able to polish some of that out with some emery cloth, but not all of it. But again, we're going to live with it and go with it. So I've come over here and we bored that in there. It's starting on here, but it's just not quite wanting to just slide right on, which is good. We want a good tight press fit. But instead of pressing it on, I think what I'm going to do is I'm just going to take the torch. I'm going to heat this up a little bit. Just a common trick for pressing things on. If you'll heat up the outside part, it will expand it just a little bit, and it'll probably just drop right down on there. At least that's my hope. If not, we can tap it on there. I could probably take a hammer and tap it on there now, but I would rather heat it up and then let it shrink back in place to get a real good tight fit, and then we're going to have to drill it and pin it. So anyway, we'll go ahead and get going with this here in just a second. All right, we're set up over here. I've got this on the milling machine, the horizontal mill, because I do need to drill that hole through here when we get through. So I figured we just go ahead and set up. They give me a good surface to pound this down on. We'll get everything lined up. Everything is in the center now. I'm not going to try to reuse the hole that's in there. I'm going to instead drill a new hole right above it, just so that I can make sure that I got a good fit all the way through there. It's going to be real difficult to get this drill bit lined up exactly with that old taper that's in there. So we're just going to make a whole new one that'll have a good taper all the way down for that pin to go into. So I've got my tube here. We're going to put some heat on it with a torch. Again, not trying to get it red hot, but just trying to make it expand a couple thousandths of an inch. While we're here, drop that down on there. May tap it down with a hammer. Once we get up there, we'll have to see. Hopefully it'll just fall right in place. We'll let that cool, and then we'll drill it and ream it. So let's put some heat on this and get going. That should be enough heat. Let's see if this will drop down on there. Perfect. All right. I'm going to get a rag and we'll wet rag and we'll cool that in place. All right, we've got the machine running at 529 RPMs, and I've got my feed set to a 1/2 inch per minute, and we're just going to let this let the feed on the machine feed it in place. We'll engage that, and we're drilling. All right, the hole is drilled. We're going to now come in here and ream this. So I'm just going to squirt a little bit of Tap Magic in there for some lubrication. And I've got a number 4 taper reamer here for taper pins. And we'll just start working our way through there. I got looking in my collection of tapered reamers, and I realized that I have a chucking reamer that's a spiral, which would be a little bit quicker than doing this all by hand. So I've just chucked this up in a cordless drill and have come in here and just letting this ream that out. You know, one thing with tapered reamers and tapered pins is that the taper on this is 1/4 inch per foot. It's not a very steep angle at all, but because of that, you can really make a big difference on the depth of a pin by just a little bit of depth with that reamer. So we're going to just kind of take it by easy and work our way through this thing. Probably just a little bit more and it'll knock in the rest of the way. All right, I think that'll knock in. Grab a hammer. Man, that's going to be nice. All right, that's good. I've got that pin just a little bit below the surface here, and it's not quite through on the back, which is just where we want it. I will probably have to deburr this just a little bit so that it will slide up over that pin, but that pin is in place, and that part is in place. It's pressed on with a shrink fit and pinned in place, so we should be ready to go. So the fence tube is now installed. Everything is working good. This is sliding just like it should. What I will do is I will wax this up real good so that it stays real smooth on there. So we've still got a few more things left to do to this before we're going to call this it completely rebuilt. Probably the next thing is going to be making the new knob that goes in here that will match the other ones that are on here, getting that back correct. The pin, I've still got to drill and pin that. However, the original on this has a micrometer dial on this. So as you turn this, you can actually measure your fence adjustment in thousandths of an inch on this dial. So there needs to be 50 gradations around this little flange area here, and we're going to go back and do that. I need a dividing head to do that, and right now I've got a dividing head I've been working on kind of getting built back up, but I don't have a chuck for it to mount this in. So when we have our weekend event here in about another week, Adam Booth, A-Bomb 79, is going to bring his dividing head down with him when he comes, and we're going to use it, and we'll put those gradations in there where we can finish that. But I don't want to finish that up until we get that last little thing done. So that's really about it that's left on this. We'll probably go ahead and just run a 1/2-inch reamer through these, make sure these are clean, and then we've got to make the new pins to pin this down to the table. Actually, Mike Wiggins, who is going to be coming next weekend, he said he was going to make those and bring those with him, these pins. So I sent him the drawings and dimensions on those. So Mike's going to do that little project for us and bring them with us when he comes next week. But we're making good progress on this, just about through. Like I said, we'll get this one other piece done, and we should have knocked out what we can get knocked out on it before the weekend. So this about wraps up the fence restoration. We got the last little locking knob here made, so this just goes up in here. So in here we just got this piece here. It's got a little bevel on it. That actually comes up onto the tube, and it's this piece here that locks this in place by just some pressure. So this screws right in here, and right there, that is now locked. It won't slide. So it slides in the back tube, but this is here, and of course you can use the micrometer adjuster here to adjust this in and out. So that's all done now. So in summary, you know, we replaced these rods here, which were very rusted out. Got those brand new again. We replaced all the lock knobs on here, which again were in pretty bad shape. There were 3 of them. We redid the micrometer adjuster here, which was again just rusted out real bad, and then made a new tube that again was rusted out real bad. So this is pretty much ready to go. The only things that are really left to do on this are the 2 pins that will pin it down to the table, and excuse me, Mike Wiggins is going to make those and bring them along next week. I could do it, but Mike wanted to help out, and that will save me some time actually, so to give me some time to get some other things ready for our event next weekend, or this coming weekend now. I also need to make the handle, the lock knob that screws into the table that locks it in place. and that will probably get made during the event weekend. So we're going to call this done for now, and like I said, we're looking forward to folks coming in on the weekend of June 6th, 7th, and 8th to come help with the rest of the restoration 2014. So if you're watching this video this week, there's still time to come. If you're watching it later on, we'll try to do some more of these project weekends out at the museum and try to get some folks to come in if they'd like to, at the Georgia Museum of Agriculture in Tifton, Georgia. So that's about it. Thank you for watching, and thank you for my many subscribers who are out there.